Hello everyone, thank you for stopping by. My name is Bino, and in this video we'll determine the particular solutions of the following separable differential equations. The first step, we have to arrange the dy on the left hand side with the function of y, and the only function of y that we have is the y squared. And on the right hand side we are going to arrange the dx with the function of x, and we have that as the function of x. And after that we introduce the integral sign both sides of the equation. On the left hand side we integrate with respect to y, and on the right hand side we integrate with respect to x. And after the plus c, we have to determine the value of the c using that initial value, because we are looking for the particular solution and not the general solution. So we have the dy divided by the dx, which is equals to x into e raised to the power x squared plus 2, and this is divided by the 6y squared. We multiply both sides of the equation by the dx, and that dx will cancel out, and the dy will be equals to x into e raised to the power x squared plus 2 multiplied by the dx. This is divided by the 6y squared. We have to group the y squared with the dy on the left hand side, so we multiply both sides of the equation by the y squared, and that y squared and that y squared will cancel out, such that y squared multiplied by the dy will be equals to x into e raised to the power x squared plus 2 multiplied by the dx. This is divided by the 6, and from here we introduce the integral sign both sides of the equation. So we'll have the integral of y squared dy, which will be equals to the integral of, we can take this 1 over 6 out of the integral, and inside the integral we'll have the integral of x into e raised to the power x squared plus 2 multiplied by the dx. The integral of the y squared will be equals to y to the power 2 plus 1 divided by 2 plus 1, and we have 1 over 6 multiplied by the integral. So we have the integral of x multiplied by e raised to the power x squared plus 2 dx. We are going to let u to be equals to the x squared, and the derivative of the u with respect to x will be equals to the derivative of the x squared, which is the 2x. From here we multiply both sides of the equation by dx, and that dx will cancel out, and du will be equals to 2x multiplied by dx. We rearrange our integral as the integral of e raised to the power x squared plus 2, and later we write the x and the dx. We have the x dx, and there we also have the x dx. So let's divide both sides of the equation by 2. So we have du over 2 will be equals to x multiplied by the dx. So we have the integral of e raised to the power x squared, but in the place of the x squared we substitute u plus 2, and in the place of the x dx we substitute the du divided by 2 because it's equal to the x dx. We take the 1 over 2 out of the integral, and we have the integral of e to the power u plus 2 multiplied by the du, and this will be equals to 1 over 2 multiplied by the integral of e to the power u, which is just e to the power u, and the integral of that 2 with respect to u will be equals to 2u plus our constant c. We substitute back the x squared in the place of the u, so plus 2 multiplied by x squared also in the place of the u plus our constant c. We substitute this on our integral, so we have 1 over 2 multiplied by e raised to the power x squared plus 2x squared plus c. We distribute the 1 over 6 inside the parentheses. So y to the power 2 plus 1, which is 3, divided by 3 will be equal to 1 over 6 multiplied by the 1 over 2 into e raised to the power x squared plus 2x squared plus the c multiplied by the 1 over 6. From here we distribute the 3 inside the parentheses, and that 3 will cancel out, and y to the power 3 will be equals to 3 divided by 12 into e raised to the power x squared plus 2x squared plus c multiplied by 3 divided by 6, and we let c1 to be equals to the c multiplied by 3 divided by 6. So the y to the power 3 will be equals to the 3 divided by 12, which is 1 over 4, into e raised to the power x squared plus 2x squared plus the c1. From here we have to determine the c1 using the initial value that is given. The y of 0 is equals to 1. So we have the y of 0 is equals to 1. That is to say, when x is equals to 0, then y is equals to 1. In the place of the y, we are going to substitute 1, and this will be equals to 1 over 4 into e raised to the power. In the place of the x, we substitute 0, and the 0 squared will be 0, plus 2 multiplied by the 0 squared plus c1, and 1 will be equals to 1 over 4 into the e raised to the power 0, which is equals to 1, and the 2 multiplied by 0 squared will be equals to 0, and we have the plus c1. We take the 1 over 4 to the left, and it's going to turn into negative 1 over 4. And this will be equals to the c1. And 1 minus 1 over 4 is equals to 3 divided by 4. So we can now plug the c1 into that equation. So let's copy and paste. And in the place of the c1, we are going to substitute the 3 divided by 4. From here, we make y the subject of the formula by introducing the cube root both sides of the equation. So we have the cube root of y cube, which will be equals to the cube root of 1 over 4 into e raised to the power x squared plus 2x squared plus 3 divided by 4. The cube root and the cube will cancel out, and y will be equals to the cube root of 1 over 4 into e raised to the power x squared plus 2x squared plus 3 divided by 4. For our second question, we have the following second order separable differential equation with the initial conditions: dy over dx is equals to 3 over 5, x is equals to 1, and y is equals to 1 divided by 5. We have the x squared, which is multiplied by the second derivative of y with respect to x, and this is equals to x to the power 6 plus x cubed minus 2x squared. We divide both sides of the equation by the x squared, and that x squared and that x squared will cancel out, such that the second derivative of y with respect to x will be equals to x to the power 6 plus x cubed minus 2x squared, and each and every term will be divided by the x squared. So every term on the right hand side is divided by the x squared, and that x squared and that x squared will cancel out each other, and the second derivative of y with respect to x will be equals to x to the power 6 plus x cubed minus 2, and since the denominator and the numerator have the same base, we will minus the exponents. So this will be 6 minus 2, and here we have x raised to the power 3 minus 2. And the second derivative of y with respect to x will be equals to x to the power 4 plus x minus 2. On the left hand side, we have the second derivative of y with respect to x. If we were to differentiate this, we will get the third derivative. But if we were to integrate this, it will take us back to the first derivative of y with respect to x. So for this reason, we are going to introduce the integral sign both sides of the equation. On the left hand side, we have the second derivative of y with respect to x, and we are introducing the integral with respect to x, and this will be equals to, so we also have to introduce the integral on the right hand side. So we have the integral of x to the power 4 plus x minus 2. We also introduce the dx, and the integral of the second derivative of y with respect to y will be equal to the first derivative dy over dx. This will be equal to the integral of x to the power 4, which is equal to x to the power 4 plus 1 divided by the 4 plus 1. The integral of the x will be equal to x to the power 1 plus 1 divided by 1 plus 1. And the integral of the negative 2 will be equal to negative 2x plus our constant c. From here we simplify. The first derivative of y with respect to x will be equals to x raised to the power 4 plus 1, which is equals to 5, divided by 5 plus x squared divided by 2 minus 2x plus c. But we have to determine the numerical value of the c using the initial values that we were given, as dy over dx is equal to 3 over 5, x is equal to 1, and y is equal to 1 over 5. So we have dy divided by dx is equal to 3 divided by 5, and the value of x is equal to 1, and the initial value of y, which is equal to 1 divided by 5. So in the place of the dy divided by dx, we substitute the 3 over 5, and this will be equals to, in the place of the x, we substitute 1. So 1 raised to the power 5 will be equal to 1 divided by 5 plus 1 squared, which is just 1, and we divide this also by the 2, minus 2 multiplied by 1, which is just 2, plus our constant c. So the 3 divided by 5 will be equal to 1 divided by 5 plus 1 divided by 2 minus 2, which is equal to negative 13 divided by 10 plus c. And from here we take this negative 13 divided by 10 to the left, and it's gonna change sign from negative 13 divided by 10 to positive 13 divided by 10, and this is equal to the constant c. And our constant c will be equal to 3 divided by 5 plus 13 divided by 10, which is equal to 19 divided by 10, which we can also express as 1,9. So we have determined the value of c as 1,9. So we substitute the 1,9 into that equation. So we copy and paste. So let's paste this, and our first derivative of y with respect to x will be equal to x to the power 5 divided by 5 plus x squared divided by 2 minus 2x, and the constant c we determined as positive 1,9. So from here we have the dy divided by dx, which is equal to x to the power 5 divided by 5 plus x squared divided by 2 minus 2x plus 1,9, and we are going to multiply both sides of the equation by dx, and that dx will cancel out, and dy will be equals to x to the power 5 plus x squared divided by 2 minus 2x plus 1,9, all of which is multiplied by dx. We introduce the integral sign both sides of the equation. On the left hand side, the integral of 1 with respect to y will be equals to y, and this will be equals to 1 divided by 5 multiplied by the integral of x to the power 5, which is x to the power 5 plus 1 divided by 5 plus 1 plus 1 over 2 multiplied by the integral of the x squared, which is x to the power 2 plus 1 divided by the 2 plus 1, and the integral of the negative 2x will be equals to negative 2 multiplied by x raised to the power 1 plus 1 divided by 1 plus 1. Let's create some space. The integral of the positive 1,9 will be equals to 1,9x plus our constant c1. Let's try to simplify. Y will be equals to 1 over 5 multiplied by x raised to the power 6 divided by 6 plus 1 over 2 multiplied by x raised to the power 3 divided by 3 minus 2 multiplied by x raised to the power 2 divided by 2 plus 1,9x plus c1. Further simplification, we have y, which is equal to 1 over 5 multiplied by the 1 over 6, which is equal to 1 over 30 multiplied by x to the power 6 plus 1 over 2 multiplied by 1 over 3, which is equal to 1 over 6 multiplied by x cubed. 2 and that 2 will cancel out, and we have negative x squared plus 1,9x plus our constant c1. From here, we have to determine the value of c1 using our initial values. This time around, we are just going to use the x is equal to 1 and the y is equal to 1 divided by 5. In the place of that y, we substitute 1 divided by 5. So 1 divided by 5 will be equals to 1 divided by 30. And in the place of the x, we substitute 1. So 1 multiplied by any number will just be equal to that number. So we have 1 over 30 plus 1 divided by 6 minus 1 squared, which is 1, plus 1,9 plus c1. And the 1 divided by 5 will be equals to 1 over 30 plus 1 divided by 6 minus 1 plus 1,9, and this will be equals to 11 divided by 10 plus c1. We take this 11 divided by 10 to the left, and it's going to change sign to negative 11 divided by 10, which is equals to c1. So the numerical value of c1 will be equal to 1 over 5 minus 11 divided by 10, which is equals to negative 9 divided by 10. So the value of C1, we substitute it into this equation. Finally, our particular solution, we have y is equals to x to the power 6 divided by 30 plus x to the power 3 divided by 6 minus x squared plus 1,9x plus, in the place of the C1, we substitute negative 9 divided by 10, and this will be our particular solution.